Hello, my name is Eugene Kravchuk, and today we'll be talking about aromaticity. And the question is, are you aromatic or not? There are four different rules to aromaticity. The first rule is number one, is the ring. A molecule or compound has to have a ring and able to be aromatic. Number two is this ring has to be planar, meaning that it has to be aligned with the surface. It can't be coming out. Rule number three is that all atoms have to have p orbitals or lone pairs of electrons on the ring. So if there's a carbon that doesn't have a set of p orbitals or a lone pair of electrons, then it cannot be considered as aromatic. And lastly, the rule number four says that it has to follow Huckel's rule. And you may ask, what is Huckel's rule? Well, Huckel's rule is an equation for n plus 2 equaling to a number of electrons on a ring. So for example, when we look at this cyclohexane ring, we can see that there are 1, 2, 3 double bond electrons, double bond carbons, meaning that for each double bond we count them as 2 electrons. So we have 2 electrons here, 2 electrons there, and 2 here. So we have a total of 6 electrons. So let's see. Rule number one. Is it a ring? Yes. So follows that rule. Is it planar? Yes, it is. Also, does it have all atoms have p orbital or lone pair? And here we see that yes, they do. And last, let's try the Huckel's rule. So we take 4n plus 2 equal that to 6, and then when we solve for n, we get 1. Now let's look at this compound. This looks a little trickier. So this is, as we look at this is a ring. So it follows the rule number one. Number two, it's planar because there's no stereochemistry there. Number three, we have to check because there we see double bond, which has a p orbital. Here we see double bond, but there we have an oxygen with 2 lone pairs of electrons. And in the rule it says that we can have lone pairs. And when we use them to contribute towards aromaticity, we only have to use 1 lone pair. So there's 2 electrons here, 2 electrons there, and 2 electrons here. So in total we have 6 electrons. And when we plug in Huckel's rule as from the previous example, we get exactly n equals 1. So this compound is aromatic. Another case, as we see here, with the ring that has boron in it, we take a quick look, we see that this is a ring, obviously, and that it is planar. But also we kind of think about the amount of p orbitals that are included. So here we see 1 double bond, 2 double bonds, and here we just see boron connected to 3 different molecules. But in the rule it says that all molecules, all atoms have to have a p orbital, not necessarily filled ones. A boron is in a p orbital, even though the p orbital is empty, it still has a p orbital, so we consider that as having a p orbital, so it fulfills that area. Now when we move to Huckel's rule and we see that there's only 1, 2, 3, 4 electrons that we can use, when we plug it into an equation for n plus 2 equals to 4, when we solve for n, we actually get 1/2. This means that it doesn't follow that rule, and it would put this molecule in an anti-aromatic situation. Lastly, we will look at this ring. So it fulfills rule number 1, it's a ring, and it's planar, so rule number 2 is fulfilled also. When we move on to rule number 3, which says that all atoms have a p orbital or a lone pair of electrons, we see that there's a double bond over here which contributes to 2 electrons. A double bond here contributes to 2 electrons also. Here we see an empty orbital, or it's lacking, but it's a p orbital considering the fact that it has a plus on it. So this goes well. But the problem is right over here. This is not a p orbital. It's just a simple sp3 carbon. So that means that it doesn't fulfill that rule, putting this molecule into that non-aromatic situation. So that concludes our little lesson about aromaticity. There are many more molecules that you can use to practice for aromatics. And I hope that your studying goes well. Have a great day.